What if I told you that modern physics tells us that the past is just as real as the future? So what we consider reality, what we consider now, what we consider tangible and empirical is just as real in the future as it is now. And you might think, okay, well, it will be, but what is the past? And how can the future actually be real if it hasn't occurred yet? I mean, who knows what's going to happen? And yet Einstein's special theory of relativity tells us that yes, the future is just as real as right now, just as tangible. All of the physics are there, the same with the past. It's just as real and tangible, and all the physics are there, just as in now. And that there really is very little difference. And let me explain how that happens. It comes from the principle that we measure light at the same speed, no matter what your frame of reference. So if you're traveling along this direction and the light's going along this direction, you'll see the light traveling at light speed. Or if you're going in this direction and the light's going in this direction, it's still going to look like it's going at light speed. And without going into the physics of that, let's just take that as an observed experimental fact that happens. And what that implies is that if we're going to measure time with light, it makes it an easy way to explain this. I have two mirrors and I have a laser beam bouncing back and forth. So each time the laser beam hits one of the mirrors, that's a tick of the clock. And successive ticks measure off successive events and time. And so if I'm here on Earth and I've got my little clock with my laser beam going, and then I decide to get in a rocket and I take off really fast, then that clock is going to look like it's moving down. And so each successive tick of the clock is actually going to travel a longer distance as I see the clock moving down below me. And so what that means is that even though light is traveling the same speed, now it's traveling a longer distance between each tick of the clock, meaning that time is traveling slower on Earth relative to me in the rocket. Well, the same also applies if I have a clock on the rocket and I'm allowing my laser beam to go back and forth and measure off time. Then as this clock is moving up, we on Earth will see the laser beam taking a longer distance between each successive tick of the clock than what I saw on the rocket, meaning that while I'm on the rocket, my clock moves slow relative to the Earth, and the Earth, their clock moves slow relative to me on the rocket, which means that there are reference frames where simultaneous events in one reference frame are not simultaneous in another. So that something that occurred at the same time in one reference frame took place at different times in another one. So that if you think of the Earth and the sun and the solar system and the galaxy traveling through space, there are reference frames that are traveling a lot slower than us, and we can come up with reference frames that are traveling a lot faster. So that events that we consider simultaneous might have occurred at completely different times in these other reference frames, whether it's the past or the future, and they're every bit as real as the one we have now. Yeah, that's crazy.